Okay, let's begin. Let me share the screen, and I am recording this. Okay, can everyone see my screen?
Yes.
Yep.
Okay, so this is the topology from last weekend, and hopefully you wind up with something like this. And the problem, so what is the problem? Why can't can PC1 ping PC2? Let's see. Let's go on. Let me see. Yes, we have that's DHCP static configuration. So if everything is right, then PC 0 should ping PC1, and PC1 should swing PC should be able to ping the interface on this switch. Okay. And hold on, I had to let somebody else in. Admit all. Okay, but the question is, can this if the PC can ping its respective, if each PC can ping its respective switches, okay, can the PC then ping this route? Can they ping the server here? Um, can somebody tell me yes or no? Well, the answer is
Uh,
no. The answer is
oh,
no because this is these connections are switched, and actually, let me just take a look at the command line interface right here. Let me do a show run, and let's see IP. It's okay. So I have the IP pool commands in here. So let me go ahead and try to enact DHCP, and let me do that. So let me go to this PC and go to DHCP. It should work, and it does. And let me go to this desktop and let me do DHCP, and this works. Let me configure this PC for DHCP, or hopefully that works, and it does. And finally, let me use DHCP. Okay. Can Just so everyone knows, the reason why these IP addresses started to become that started with I-169. That's the APIPA address. That is the automated private IP addressing system for PCs that cannot connect to their default gateway or cannot request a DHCP. Now, according to the show run output, right here, we have obviously configured for DHCP, but the problem is I had already had this topology, all the configurations in, and then when you start Cisco Packet Tracer, the first thing that happens is the PCs activate and they turn on, and they make a and that's before the switches configuration is executed. So anytime if your PC is initially configured for DHCP and it can't connect to its DHCP server, it's going to get a PIPA IP address, which is automated IP private IP address, and it always starts with 169. So if the moral of the story is, if you ever turn on your computer, like at school or even at home, and your IP address happens to be at 169 something, then that's the APIPA address, and that means that your PC tried to communicate to its DHCP server, but it could not, and thus it receives this random 169 IP address. So the idea is that if everyone gets the same, it gets the same 169 dot whatever IP address, then you can ping each other. You just can't ping outside your network. And the reason why that was very popular was because mostly there were, in the 80s and 90s, most assets that you needed, whether you worked for an engineering firm or whether or not you worked for a school system or whatever, most of the assets were on site. So so as long as your server, your engineering drawings or your printers or your fax machines were in your local area network, meaning within that 169, I was almost going to say zip code or area code, but IP address domain, you can still ping them, and arguably you can still get them to work. You can still reach them. But in 2025, that's not realistic, just because most everything is beyond our local area network, because simply of the presence and uprising of cloud protocols, cloud networking. Everything we need is in the cloud. And of course, what was, when COVID happened, we were primed for that already. When I say primed, it's like starting your lawnmower. You got to prime it before you actually pull the string and it actually starts. Well, we were primed when COVID occurred, because when COVID happened, everyone had to stay home, right? Well, everyone stays home, and the servers that they're working with, all their information, all their apps, quote unquote, were still at work. So you had all these gateways and all these, I'm going to say VPNs that were improved. I mean, VPNs have always been there since the first cloud network you could say was mainframe in the late 60s. So IBM will always say, hey, we created everything. But I mean, when COVID happened in 2020 and 2019 and 21 and 22, like we were able to augment our existing infrastructure, and the data servers or the data centers that were using NVIDIA chips and whatnot. They all, like all of those companies, received unprecedented investment, unprecedented stock prices, unprecedented monies dedicated to R&D. So now NVIDIA, for example, has their 5090s, which are geared for data centers, although they now have separate lines, one for data center, one for others. And when I say others, I mean, data mining, and also for graphics cards for actual higher end PCs, because they use AI. But what I'm saying is that it just things have moved on. So everything we need is in the cloud. Okay, so a PIPA is no longer a realistic, really solution. So that's why we need to make sure that the DHCP server is active first. So I'm not going to go over the configuration of DHCP servers because we've already done that. Okay, and that for here we did not do we just simply did the static IP configuration right here. So that's because it's just a transport. Okay. Now let's take a look. What was our IP address here? So let's go to config and G10, and we didn't even. I could have sworn I had you guys put an IP. I did not, because this is switched. So I would not have. This is a switched network. So let's go ahead and configure routing. And what I'm going to do is I'm just going to configure routing from here over to here and over to here. So the first thing we have to do is we have to these are multi-layer switches, also known as layer 3 switches. First thing we're going to have to do is connect a crossover cable, and we can connect. We'll just do gig 10/2 to gig 10/2. Here we have an example of symmetrical routing. Now I wanted to say we'll have to. So in order for this PC to message this server, because they're outside of our existing network, we will actually have to do routing, and routing needs layer 3 information. Okay, it's layer 3 addressing. So we're gonna say, in order for switch 1 to get to this server, it's obviously we can have it go through here, and then we can then have it go from here to here, and then it'll connect to this server. So we're going to click. I know that's not the most efficient, and this is probably not the most realistic topology, but I just wanted everyone to get a flavor of the difference between layer two responsibilities and layer two, assets and advantages and things like that. What can layer two do for you, and what can layer three do for you? So layer two here, it's just these are switch networks. So this creates a layer two connection, but we can only connect from a switching perspective. Like if a server was connected here, then this PC would be able to connect to that server. But because this server is beyond this router, and it's over here, we have to create a layer three. Now we could create a layer three towards here, but I just want to do this kind of from scratch. I just want to do it this way. So from here, G1/0, let's go to this, and let's do Control Z to get us back to this pound sign. Let's go to global configuration. Let's do no IP domain lookup. Okay, and let's go to this interface G1/0/2. Okay, now what's the command to put an IP address on gig 10/2?
Is it IP add?
IP address, right? Right. So let's try to put it on IP address, and it's going to not work. I'm press enter and invalid input. Why is it invalid input? Well, what's the command we can use for?
Because you didn't put do.
No.
Because you didn't put the IP address in the subnet mask?
No, because it says invalid input, not incomplete command. If it was a valid input, it would have said, incomplete command. What's the command what's the character we use to check all available commands at this particular level?
Is it show IP interface brief?
No, it's one character. It's called contextual help. What do you use when you ask, if I were to write a book, and the main character says, "How was your day today?" What's the last character in that sentence if you were to write it? What's the last character?
Why?
No. Okay, if you're writing a script or a book and you say the lead character asks, how was your
end? The end?
No, how was your day today? What's the last character if you were to write that down?
Question mark?
Yes, question mark.
Oh.
So with the question mark, we can see all available commands. I've done it before, but we can see all available commands. IP.
So cool.
Wait a minute. Where's address? Where'd it go? Why can't we put an IP address? What's going on? Is this a bad switch? Is this a bad layer 3 switch? Probably not, since it's in synthetic, so everything's perfect.
That's not where we do the IP address, not in the CLI. Do it and think in config?
No, well, I mean, we can do it in config. Let's take a look in config. That's a good idea. Here it is. Where's gig 102?
Where it says iOS commands, that's where we put it.
Wait a second. Even in gig 102, there's no room for IP address. It just talks about VLANs and ring limit. What's going on? It does say port status, and then it does indicate duplex. Okay, it does do that, but where's IP? Well, is it because But it's a multi-layer switch. Didn't I tell you before? We can put IPs on the interfaces. But
Yeah,
where's
we should like choose the interface. Like, do we choose like Giga and Gig Ethernet, like the one that we want, and then we put the IP address?
Well, what did I say? A multi-layer switch started off always at a by default.
Just a switch.
Yes, it's just a switch. So is there some command that we can put just on this interface that could turn it from a layer 2 to layer 3? I went over it. Okay, because time is not...
But I forgot.
Yeah, it's okay. It's okay. Just so everyone knows, when you're out there in the real world, in any information technology job, you never have to have all the answers. Okay? Do you think is Stephen, how many of you ever heard of the writer Stephen King? Hopefully you have. Any writer out there, you think if you look at Stephen King's if you look at any desk of a writer, what do you see? A typewriter? And what else do you see? A thesaurus, a dictionary, and I'm talking about in the 80s, before there was Google. So a writer would reference, constantly reference thesauruses and dictionaries. So nobody out there has all the answers. Okay? So it's okay that you didn't know, or I'm sure you did know. And I'm going to give you the command, and you're going to say, oh, shoot. We should have known because you went over this. The command is no switch port. I went over that several times in the videos, but that's okay. We can't always know everything. That's okay. Now I'm gonna look at I'm gonna use contextual help with the question mark, and there's more commands and different commands. I mean, it's actually different commands, not. Well, I mean, let's see. Channel protocol. We can do channel protocol whole queue. Actually, okay, every command is in here, but the commands that we can do is IP, and then let me do IP and then question mark, and look at this. IP address. Now, when we ran IP question mark before, okay, we only had, remember when I did this, when it was just the switch interface? These were the only commands at our disposal. Access group, ARP, and DHCP. That's it. Here, when after I did the no switch port, we have way more commands. Now let me do switch port again, and let me do IP question mark. We go back to just those commands. But let's do no switch port. Now let's put an IP address, and now we have to figure out how we're going to design this network. So let's do 192.168.4.0. Now this is even though this is, you know, a layer 3 switch, and it's not as antiquated as those old transport routers, we're still going to use a transport link style for our IP addressing. So what is our favorite subnet mask for transport connections? It's not /24, it's / what? All right, I know everyone's
27 or 30.
/30. That's our favorite. There's our favorite one. So let's make this transport /30, and then we'll make this 192.168. Well, let's not overlap our. Let's not overlap our networks right here, because I'm not trying to mess anything up. So let me just put this. This is 5.0, and we'll put this one right here. We'll create another connection from here to here. And then we'll say this is 192.168.6.0/30 here. Right here. So this is 4.0, this is 5, this will be 5.0, and let's create a straight through cable from gig 0/1 to gig 0/3, and let's go to this gig 0/1 and let's turn it on. And I like to at least turn them on beforehand, just to make sure we at least have the right cable. So let's go back to this interface. So IP address 192.168. Okay, so there's only 2 IP addresses that we can use, the higher one and the lower one. And you notice when I go left to right, when I configure, I go lower to higher. So because of that, I'm just going to do, this will be 4.2 with a 255, 255, 255, 252 IP address. And because time is not our friend, let's do the routing statements already. So let's do router rip, and then IP routing not enabled. So what is the command to turn this just the entire logic data plane for this layer 3 switch? So with a layer 3 switch, 2 things come into play. Anytime you have a router right here, here, let me just grab just a new document. So anytime you have a layer 3, anytime you have a device, there's actually a couple of elements to the device. There is the external that leads to the interfaces, and then there's the overall internal logic. Okay, so this is the overall internal logic, and this is the external that leads to the interfaces. Okay, now all Cisco multi-layer devices, at least multi-layer switches, will always by default have the interfaces not only in an on state, but they will also be by default layer 2. What the layer 2 means, obviously, is that when a layer 2 when just a layer 2 connection is made to a switch, the only way they communicate with each other is by their L2 address or their MAC address. Now, believe it or not, you can talk to each other. They do exchange information on a data level if you don't configure an IP address. But in order for this PC to send out anything to another PC, because we live in a TCP IP network, both of them have to have layer 2 and layer 3 information attached to them, so they can communicate with each other at all. But they still, even on a local situation, they communicate with each other only using MAC addresses. Okay, now this is a layer 3 switch. So all devices have a difference between the inside and the outside, and the outside is connecting to the interfaces. So by default, on a layer 3 switch, all interfaces by default start as layer 2. So in order for you to turn a layer 2 into a layer 3 enabled device, you literally just say no switch port. You have to go to that interface and do a no switch port. Now there's another command that we can do here to actually we can actually configure more than one interface. So we can do interface gig 1 0/1, and we can do, for example, just a simple description. We can say change number 34 on this date on 11 of November of 25. And if we go to end, and then we could do show interface gig, what was it, 10/1, and we can see, well, actually, it's not there. Let's see. We can do a show run and go to gig 101, and we can see that we have description change 34. Let me copy that. Change 34/11/25 and nothing under here, but we can actually point to more interfaces at once. So we can say interface and interface, and then we can use gig, okay, and then we can, or excuse me, we can use the range command, okay, and then we can do gig 10/1 to gig, let's say, all the way to get 10/5. Okay, now we are actually pointing to a bunch of them. Gig 10/1 all the way to 5. Okay, now we can actually shut them down if we wanted to, and all those have been shut down. And we can do a show run. We can do show run, and we can see that all 3 of these have been shut down. Okay. Now let's do a no shut to turn them back on, and then we can do a description, and we'll just call it 101. Just so I can be obvious, and we can see that they all have a description 101. Okay, so that's one way. That's a way we can configure a bunch of interfaces at the same time. But let's do something a little bit more realistic, and this is a little bit more realistic in terms of something that a real engineer would put down. Okay, so for example, we can go to show run, and we can see that description change. Okay, all right, so that's enough of that. And let's see. So let's do a show run to see where we're at, to see. Okay. Now to turn this into and as I said, there's 2 aspects of this switch, and so by default, the outside interfaces are all configured as layer 2. So to configure one or a bunch of them, we can do no switch port. So we can just use a range if we wanted, or we can go to each one that we want and just do a no switch port. The fact of the matter is, in this situation, the only 2 interfaces that actually need an IP address would be gig 10/1 and gig 10/2. Okay, so for example, looking ahead, we can look at this one, and we could configure them both. We could say comp T, and we can say interface range gig 10/1 to gig 10/2, and then let's do no switch port for both of them. So we have done, and we're looking ahead here, but I'm just saying because we know ahead of time that gig 10/2 and gig 10/1 will have no switch port, then we just did no switch port, and actually we could have done 10/3 too. Let's do that. Conf T, and let's do 3 and no switch port. So we've actually, if we would have been most efficient, we would have addressed all of these in the same range and done the no switch port. So we're actually configuring all of them at the same time. There's only one problem. I had configured this gig 010/1 with a IP server syntax. So I'm hoping it didn't disrupt it. So let me just see. So I don't think it disrupted it. Let me just make sure these guys can ping. Okay, it's successful. So I think we're good. All right. So we're going to go to this, and now we need to configure this router for to be able to and that's what I'm saying. That's only one aspect. Now the other aspect is the inside, and believe it or not, the inside is also layer 2 by default. The internal processor. Okay? Now a switch has, believe it or not, a switch has its own MAC address. So each interface has its own MAC address, and this switch internally has its own MAC address that covers the circuitry board in of itself. Okay? So because of that, the circuitry board itself is by default layer 2. So we have to do something to turn it into a router. So the only thing we need to do is do IP.
The routing protocol.
Yep, IP routing. So now, very good, thank you. Now we can do the routing protocol. Incidentally, this is a layer 2 only switch, and if we go to it and we type in IP routing, it should not work. And it doesn't work. Why doesn't it work? Because this is a layer 2 only switch. And we know it's layer 2 only because it starts with a 2, 2960. If we go into our various routers right here, we have 2960. And here we have 2950. And we have 2950 here. Okay? So can you identify which ones are layer 2 only and which ones are multi-layer? Well, that's layer 2 only. That's multi-layer because it starts with a 3. So it can be either layer 3 or layer 2. But, okay, so IP routing. Okay, now we can put in the routing commands. Network. Oh, I'm sorry. Router RIP. Network 192.168.4.0 and network 192.168.2.0. End. And I think we should be good with that. Let's go to this router right here. And configuration terminal, IP routing, and we're going to do router RIP, and then network 192.168.1.0 and network 192.168.4.0. Okay, and you know, I haven't configured this interface yet, but I know I will be routing 5.0 because I know it's directly connected. So I'm just going to do ahead of time network 192.168.5.0. End. Okay, now let's go to this this interface, gig 10/3 conf t, and because I already did the no switch port, I know I will be able to put an IP address, so 192.168. So that because this is more right and this is more left, we're going to use a higher IP address. So it's going to be 5.2 with a 255.255.255.252 subnet mask. Okay, and I'm going to do end show. Let's do a show IP route to see if there's any. Oh, there's no routes gathered yet. You think there would be this route that was gathered. I don't know what's going on. Let's see this one here. I've already routed this one. So show IP route, and still no route. I'm not sure what's going on. Let's see what's going on here. Maybe there's an interface that's off or something, that's manually turned off. We have the East network right here. And let's see, IP RIP. Let's see, no IP address. You know what? It might be this, conft, and let's do interface VLAN 1. Let's do a no shutdown for this. Change state to up. Now let's see, show IP route, and nothing there. Let's see what is going on. It could be something. Let's see if we can get these guys to ping. Failed. So let's see what's going on here. It could be something with let's see, ping 192.168.1.1. It pings. Let's do 192.168.4.1. It's unreachable. Okay, so something is up there. Let's do show IP interface brief. You know what's my favorite? And there's so many things that are on. Let's do only include the interfaces that are up. And let's see, 5.2 gig 10. That's unassigned. I thought I did these. Unless I'm going nuts. Your instructor might be going nuts. Now, if we do we did a show run, and we want to make sure that we did the networks right here, and we did 4.0. So interface gig 10/2 IP address 192.168.4.1 with a 255.252 IP address. End. Okay. So, looking at this, let's do a show IP interface brief. And let's see, 10/2 is configured. Let's look at this side. Show IP interface brief. Okay, forget that. Let's do only include the ones that are up. And let's see, 2.1 is assigned and 4.2 is assigned. Okay, so let's look at this again. Okay, now it can reach 4.1. Let's see if it can reach 4.2. It's able to reach 4.2. Now let's see if it's able to reach this side, 2.1. Okay, it's able to reach 2.1. That's always a good sign. Now let's see if it can reach this side, 2.2. Let's see. I think there will be, it'll fail first. It'll fail the first time, but then it'll work because of ARPing. Okay, now let's see what networks we have seen. We can see here. Show IP route. And we can see that there are, okay. So I'm going to stop here. Simply because I think everyone can finish this off themselves. So if you know, if you want to reference this, if you want me to send you the base topology before I started this, I can. You know, just let me know.
Yes, can you send that, please?
Yes, and you'll have a record of this. I'm going to start something new, so I'm going to collapse this. And but please just give me 2 minutes. I have to do something real quick. I'll be right back. Yeah. Okay. Before we were talking about um, layer 2 in the WAN, and what we messed with was encapsulation. Type, and whether it was HDLC, which is Cisco proprietary, or point-to-point protocol, which is standardized. We also dealt with clock rate and basically identifying whether or not an item, a piece of networking was DCE or DTE. That was layer 2 in the WAN. Now, L2 or layer 2 in the LAN, we're going to be dealing with two primary protocols, Ethernet, and we'll just say whatever the wireless element is, but they're both pretty much TCP IP. They both use the same stack. Now, in this class, 110, we're primarily dealing with the physical Ethernet. When we talk about Ethernet, we're going to presume it is a wired connection. Now, there's a lot of things. Now, layer 2 in the WAN is almost nothing. As long as you get the connection going, we really don't care. But layer 2 in the LAN, local area network, requires a lot of, well, not lot, but it requires several classes that we're going to start right now. And today we're going to talk about the notion of VLANs. And next Tuesday we're going to talk about the notion of spanning tree protocol. So this is what switches enable us to do. When I talk about switches, we're going back to layer 2 switches. So first of all, I wanted to tell you that so far, everything we've been doing has presumed that we're in a particular virtual LAN. Okay, I'm going to try to keep this as as digestible as possible. So one virtual LAN is equivalent to a layer 3 subnet, which is equivalent to a local area network. So in other words, what we're saying is that we have our local area network. But the first thing we have to understand is, just from a perspective of 190, like if we do 192.168.1.0, that means we have 2 to the 8th possible IP addresses to the hosts. So that's going to be 254 possible users. Okay, and unfortunately, it may be untenable, because if you have a lot of users, and they all turn their computer on at the same time, so this guy turns it on, this guy turns it on, this guy turns it on, they all turn it on, right? Okay, what's the one thing that each PC has to do? Yeah, very good. And that's one thing. But it actually, each one runs what they call a discovery packet. Okay? What are they looking for? Each PC configured after 2000 is configured with it to do what as soon as you turn it on? Well, this is a PC, laptop, anything. What is it? What is it just trying to discover? We only have a couple minutes left, so I'll keep this short. It's looking for an offer. Okay? Of what? What is it? What is it? Is this The Godfather? Is he looking for an offer that you can't refuse? No. He's looking for somebody to offer him up an IP address. He's actually looking for a DHCP server. Okay? So he's looking, and so hopefully there is a server out here, okay, that offers up each one an IP address, okay, and each PC, you know, I'm just going to say offers up A, B, C, D as an IP address, and there's a request for that IP address by each concurrent computer, and there is an acknowledgement. Okay, this, believe it or not, is called DORA. That is the algorithm that every PC in America right now goes through when it's turned on. Okay? When it's turned on. So what do you think it's going to do to this network if they all get turned on at the same time, all 254 possible users? Do you think it will use a lot of networking bandwidth?
Yep.
Mm-hmm. And the answer is yes. So what could we possibly do to prevent that from happening? Because, before there was COVID, you'd actually have an office of 200 or 300 people all arriving around the same time. So how can you prevent this? I'm going to say we can, and I got to finish up. We have to prevent this by limiting the amount of computers in this local area network. It's limiting the broadcast. And just so you know, this is what we call a DHCP broadcast. And that's what we have to worry about. Okay? That's what we have to worry about when we manage a network. We have to worry about limited broadcasts. Okay? So how do we do that? We create these things called VLANs. They are virtual area networks inside of our LAN. So we have our LAN and we build guardrails or virtual LANs inside of our LAN to prevent broadcasts. Because you're, as a network admin, you're not in the business of being around when the network breaks down or shuts down. It's like a Stack Overflow error in programming. How do we do that? Okay, how do we do that? I got 5 more minutes probably. Here's a command. We go to enable. Here's the command I want you to burn in your skull. Show VLAN brief. And all of these interfaces, all these ports in this switch are in VLAN 1. So let's put some of these into VLAN 2. Let's put FA02 into VLAN 2. First thing, we have to create VLAN 2. How do we do it? We type in VLAN 2. Oh, I'm sorry. We go to global configuration. We type in VLAN 2. And we can name it marketing. Or we can name it super secret. Now we go to end. And then we can show VLAN brief. And we have super secret as created. Now let's put in FA02 inside this VLAN. So we do conf t interface F0/2, and then we do switch port mode access, and then switch port access VLAN 2. End, and let's do show VLAN brief, and boom, we can see that VLAN 2 is interface 02 is in VLAN 2. Let's go ahead and create another VLAN interface, and notice it also changes the name to super secret. Let's create another VLAN, VLAN 3. Let's call this everyday stuff. Because I'm in the wrong level. Sorry about that. VLAN 3, name everyday stuff. And then show VLAN brief. Okay, and then let's put a bunch of them in here. So conf t interface range F0/3 to F0/19, and then switch port mode access, switch port access VLAN 3, and show VLAN brief, and we can see, all these interfaces in VLAN 3. Okay? It's going to end soon, this meeting, so everyone have a good weekend and prepare for some homework that I'm going to upload by tomorrow evening and due by next class. And I will be uploading if you want the starter topology, if you'd like, just send me a message. Thank you very much. Bye-bye.